30.000 lira?
Toner, kağıt, bir bilgisayar alınacaksa oradan, birisi kongreye gidecekse oradan, bir öğrencinin bir ihtiyacı varsa oradan, her şey.
Hocam
Maaş
fazla az değil mi yani, o çok az.
evet, az. Dolayısıyla kurda kuşa muhtaç oluyoruz. Dilencilik şeyine geçiliyor. Okey. Şeylerin ilkokulların yakıt parası vardır ya, devletin gönderdiği bir aylık yakıtı şey yapar ancak karşılar, onun gibi. Sonra müdürler şey satmaya çalışır. Kitap satmaya çalışır. Today we are going to talk about properties of data and the position of data in our society and relevance to computation. Thomas Edison said, I think it was in 1925 or something. He said, "A doctor of the future will give no medication, but will interest his patients in the care of human frame, diet, and in the cause of prevention of disease." Meaning that the future doctor is more interested in curing the disease, preventing the disease, rather than curing the disease. They don't want to cure the disease because that means disease has already happened. So what they will do is to prevent people going into disease. And that is an interesting fact. A lot of scientific improvements in genetics and molecular biology connected to data science tells the same thing today. So most diseases are preventable. Some of them are related to RNA mechanisms, RNA and DNA mechanisms. So if doctors will focus on prevention rather than cure, then people will not suffer those diseases. Another good message of the day is from Alan Kay, the MIT professor, and he says the best way to predict the future is to invent it. So rather than talking about what will happen next, he says if you invent it, what you invent becomes the next thing. So you can determine what's going to happen in terms of technology, rather than trying to understand what's going to happen. If you do it, you are the future. Trust and belief to science and technology is an interesting topic. There is a whole big course about it, society and science, etc. Some people just trust to the science. What science says is trusted, but they may not believe it. Some people don't believe due to political problems. For example, in the recent earthquake, some people think that it is done by United States ship. The earthquake is man-made, some people say. They don't believe in science, but they trust people at the same time. In order to solve this bad beliefs we have to rely on data. We have to be able to understand data, and we have to be able to show the truth by using data. If I say, like, the budget of Dean is 30,000 liras, you trust me because I'm your instructor, etc. But you may not believe it. So in order to make it working, I have to talk with data that I collect, so I have to show it. So with the numerical data, then you will believe what I'm saying. We have an interesting position here. Let's think about the first one, a simple arithmetical operation. If I do it, Hasan yanlış yere yazdın. If I do it manually, you may not believe me. You don't trust me. But if I do it with calculator, you trust to the calculator. You trust the calculator. It may do an error, but if I type 39275644 with the calculator, it will show some number, and you will take that number as correct. So that means you are trusting and believing the result. And sine 65 and 1/425. So these are, we do trust. We do trust these kind of machines. So, but if it starts to be like artificial intelligence, ChatGPT, etc., then we start not believing, not trusting the result of the algorithm. So at some point, if the algorithm is kind of flexible, sometimes working, sometimes not working. So if there are examples where it didn't work, we don't trust. Once we start not trusting, then it keeps going. Yalancı çoban hikayesi var ya, onun gibi oluyor yani. Bir kere yanlış yaparsa bu makine, bir daha inanmıyorsun. My friend used to have one of these machines when I was in elementary school. Exactly this machine. It was Texas Instruments. It was from Germany. His relatives were working in Germany, so it was a present. 4 big batteries. So it was requiring 4 big batteries. Whatever. There was an issue. Now he is a mathematician in one university. We were typing the number, and the calculator was waiting for a while, such as 3 seconds. 3 seconds, the screen was blank. Then the result was coming. And the result was coming correct. But my friend thought, since the screen was gone, he thought there was a problem. And he was hitting the machine. Okay, he was hitting the machine. Then after a while, since he hit the machine, it was showing the result. So then he believed that he learned how to make the machine work. Before all the operations, he was beating the machine a couple of times, and the machine was working. So his trust to the machine was like he was only able to get the results by beating the machine. years after, when we were in their house, we checked the machine, and machine was actually waiting for a while and then giving the result. So there was no need for beating the machine. We were kids, but that's how we develop belief into something. If it happens a couple of times, and if it is in the direction of what we believe, we match the model, and we follow that path. This was coronavirus. This was from coronavirus statistics from last year. And you see there are a lot of significant data needs to be computed, and it is all numbers, big data. Through big data, our life is shaped. There are children on the streets, bad habits, children in the school, top left image, children in the school are getting bad food, etc. So because we don't talk with numbers. How many of you do smoke? Tell me a percentage. Yunus Emre, giremiyor musunuz? Nereye giremiyorsunuz?
Toplantı linkini verdiler.
Buraya atarsan nasıl girecekler?
Chat kısmını giriyorlar. Toplantı gözüküyor. Katıl butonu.
Bir dakika. Bakıma mı almamışız acaba?
Hocam bazen Teams böyle sapıtıyor ya. Bence alakası yok şu an.
Kötü kod. Yok. Herhangi bir talep yok. Yani takımda olmayan. Girebilmeleri lazım. So yüzde kaç? %30. Okay. So we have a scientific evidence that smoking is good for your health. This was an advertisement from 1960s. It says scientific evidence on the effects of smoking, and it is they did an experiment, and it says after 10 months, the medical test reports that no effects on the nose, throat, or sinuses if you smoke Chesterfield. So if you smoke Chesterfield, you don't get any disease. The advertisement said it's good for your health. So let's wait. Okay, so we have to go with the numbers rather than these anecdotal issues. We have a lot of variables in our life, such as height, weight, blood pressure, blood sugar, etc. Status variables, our address, our position, the speed of the car or bicycle or whatever. Things we read, we watch, we hear. Things we select, things we push, things we clicked, things we said. And external variables like pressure, family, economy, salary. A lot of variables. So when we collect those variables, that makes, for example, Mehmet Melikşah or Ahmet Yusuf or Özlem or Hakan. So that those data makes you. So any kind of application that attacks, that processes that data will be a good application. And we see those applications like banking applications processes some part. Electronic teaching, student information system. So those variables are processed. Ahmet Mücahit. Kaydediyoruz. Artık girinceye kadar uğraşın. Giremezseniz de kayıttan dinleyeceksiniz. Application'ı yükleyin. Web'ten girmeyin. You need to download the application rather than going through the web. In the past, in the old days, there were no data recording. Söyleyin durumu. Güzel. Tabii beni duyamadıkları için. Biz yapıyoruz arkadaşlar. Şimdi giremiyorsanız I don't have anything to do. The best thing that Microsoft says is reboot the machine. Or,
hocam bu sorun şeyden olabilir. Birisi farklı toplantı açıyor olabilir. Hani farklı bir toplantı olduğunda herkes ona giriyor şu anda. Sizinkine giremiyor.
Hijack etmiş olabilir toplantıyı. Sahte toplantı yapıyor olabilirler. Şeyden denesin o zaman. Giremeyenler bir de telefondan denesinler. Benim tavsiyem telefondan denemek olur. Ben öyle yapıyorum yani. Takvime bakacaksın arkadaşlar. Duymayacaklar, yazacaklar. Siz yazacaksınız Bekir. Okay. So we create data. We have a nice explanation from 1965. I am going to read it and I want you to read it too. It is very interesting. This was from the manual. This was from the manual of a big computer system in the introduction part. One of man's first problems was to find shelter. He solved it by walking over the land until he found a cave. This was simple, direct solution to simple problem. As centuries merged into ages, he faced more problems and learned and remembered more facts. Concurrently, his brain became more active. His thinking power increased, both in rate and complexity, so that he faced more problems and learned more facts at an ever-increasing rate. Thus, caught in maelstrom of mental activity, man swirled dizzily into present. Bugünkü haline düştü. Because of the increasing complexity of the problems, men were forced to become specialists. Division of labor. Dividing the problems into sub-problems, then dividing the sub-problems, and so on. Dividing the problems into sub-problems, sub-problems into sub-problems, sub-problems. One of the categories in which some men specialized was mathematics. Other men came to the mathematicians for solutions to those problems whose factors could be expressed numerically. But the mathematicians soon found that two types of problems were arising more and more frequently. Mathematicians. One, problems of such complexity and their solution were impossible by pencil and paper. Two complex problems. Second, problems whose solutions for any given case were possible, but it has to be repeated for the case after case until they become so time-consuming that the mathematicians had no time left for other work. So tedious work. These two problems are fundamental data processing problems with the computers. So the mathematicians turned to engineers and asked for development of machines to help man in the generation of solutions by increasing the speed at which each mathematician could work. The engineers responded with various assorted combinations of keys, wheels, gears, cams, which we refer to as calculating machines. A calculating machine was placed on the mathematician's desk and called a desk calculator. This man-machine system generated solutions at highly increased rate, making possible more solutions per mathematician. But increased demands upon mathematicians soon surpassed even the most efficient man-machine system so far. Engineers were called again. This time they switched to electronic equipment. Use of electronic circuit greatly reduced the time necessary to perform arithmetic operations to the point where a single operation, such as addition, could be performed in few microseconds or nanoseconds. This new type of machine was called as digital computer. The analog computer, on the other hand, some engineers did not switch entirely to electronic circuits. They combined them with the mechanical features of the old calculating machines, like Charles Babbage's machines, developing a computing machine which used mechanical operations to represent arithmetic and physical quantities, such as degree of rotation of the shaft. 60 is equal to 60 degrees. 30 is equal to 30 degrees. 60 plus 30 means more rotation. Okay. This type of computer is called the analog computer. The accuracy of an analog computer is limited by the accuracy where the physical quantity can be measured, such as this. This navigation computer of the ship or space device or rocket. So these are the variables. So the variables change here on the right side with the spring, changes with the analog variables. If you measure it, the result will be analog. Digital computers using electronic circuits represent numbers and quantities with digits. Any desired degree of accuracy can be obtained through adding more digits. Therefore, greater accuracy can be obtained in this type of computer. Most digital computers are general purpose, designed for a multitude of uses, scientific and commercial. This was from this manual. The name of the machine is Bendix G15. They sold a lot of machines, and this is the machine. The computer is this, and what we read is from the preface of the manual. So the processing data. When we deal with the environment, we change it. We observe the result, we make decision, and we continue. That's why we make cities, buildings that fall down in the earthquake. So we change the environment. Yanlış olmuş. Through 5 senses continuously, we make measurement and evaluate using our brain, and we live. Modern human uses not only 5 senses, but also uses the measurement techniques and tools to understand surrounding environment and process to the external world. So we use tools to understand our environment. Collection of measured and obtained variables are called data. So if we measure and get the information, that is what data is. Data can be classified in the following primary groups. It could be qualitative or quantitative. Qualitative data is also good. Beautiful day. Quantitative is related to measurement. The measured that data could be integer, which is discrete, or continuous or discrete. Data about the dog, for example. Qualitative data is the brown, long hair, powerful, etc. Quantitative data has 4 legs and 2 brothers. When we say continuous, it is 25 point something kilogram and 85 point something centimeters. However, in the computer world, continuous data is interesting. For example, the length of this paper is continuous variable. The length is continuous, but if I measure it, it becomes discrete because the resolution of floating point number is limited in the computer. However, if I measure it and keep it like this, it becomes analog and continuous. But in terms of statistics and data processing, discrete means integer related or categorical. So one fundamental part is the statistics. Statistics, what is that? It is the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a representative sample. So statistics for coronavirus, statistics for earthquake, statistics for student attrition, statistics for anything. So get some sample, measure it, and make a conclusion. And statistics for political events, etc. Voting is, for example, statistics. Collecting, classifying, presenting, interpreting, and making conclusion. The term descriptive statistics is actually you don't have any idea, you just lay out and data speaks for itself. For example, if you smoke, you die early. Okay, there is a statistics for it. You don't have to say anything else. If you smoke, you will die earlier. It is a fact. But since you are young, you don't understand it. Inferential statistics is more related to cause and effect of the data. You die earlier, fine, but why are you dying? Because it affects in the lung in a certain way, and then it affects you are more likely to get cancer, and then you will die earlier, etc. So it's inferential statistics to make more rigorous conclusion. In the old days, how do we get data? In the old days, data were collected manually just by asking or going and measuring data collection. Today, computer techniques are improved. Smart devices, IoT devices are collecting data in a very fast way. So number of data sources increased. In the old days, a factory owner didn't have anything else than the daily reports of the production. How many, let's say, how many chairs we made today. But with the with the electronic equipment and data collection possibilities, now factory owner can monitor efficiency of each machine on the plant, efficiency of each worker, so he or she can optimize it. So number of data source increased. Now, since number of data sources increased, number of sensors are increased, standard databases become insufficient, then we call the problem of big data. Big data is the elephant on the right. The term data warehouse stands for servers that we put data for later processing. Database is active. Data warehouse is not that active. It's more for processing or analysis. Data warehouses are repositories of integrated data from one or more sources. They store current and historical data in one single place so that people can connect to database, connect to data warehouse database, and make some conclusion. Data stored in the warehouse is uploaded from the operational systems such as marketing and sales. Marketing and sales have their own database. With the growing acceptance of microservices in the industry, we are seeing more and more independent databases for each small task because it is microservice architecture. Then all these data is combined into a big data pool, data warehouse. If we are going to make analysis, we make analysis on that big data pool, either data warehouse or some people today call it as data lake. I haven't heard anything called data sea, but data lake term is used frequently today for the big data applications that are getting data from different sources. Data warehouse is kind of older terminology. Unfortunately, these terms do age over time. So today, people say data lake instead of data warehouse, because it is no SQL type. When you collect data, significant amount of work is required to clean it. Clean data is interesting and helpful. There is a task type called as ETL or ELT, extract, transform, load, is related to transferring and processing data from one system to another. Tasks in universities, banks, government, many tasks are ETL tasks. In Turkish, you may call it as hammaliye, but that is what it is. Extract, transform, load tasks and extract, load, transform are two main approaches that we use to build a data warehouse system. Majority of the work required and critical work required in companies are ETL tasks. The term big data refers to data that is so large, so complex, and fast coming, so that it is difficult to process using traditional methods. What was traditional method? Traditional method means SQL, structured query language, using tables, because inserting those information into tables takes time. If it is coming in a too fast way, standard database engines fail. Then what? There are no special tools to assess, examine these big data types. The keyword NoSQL is used for that purpose, and two main examples are Spark and Hadoop. Those are famous big data processing tools that are popular today. In the big data, we have 5 V's: volume, variety, velocity, veracity, and value. Volume is too much data. Variety, very different type of data. Velocity, coming too fast. Bunu ben şeye benzetirim. Filmlerde, çizgi filmlerde ya da gerçek filmlerde görürsünüz. Kediler veya da köpekler tuvalet kağıdını boşaltırlar. Şeyden açarak, sargıyı açarak. Hepsi yığılır, böyle tutamazsın falan. Ya bir yerden çok fazla bir şey gelirse koyacak yer bulamazsın. Yetişmen lazım ona. Big Data böyle bir şey. Çoğunlukla sensörlerden geldiği için yazacak yer bulamıyorsun, disk bulamıyorsun. İşleyip de onu anında işleyip sonucunu saklaman lazım. Yani ben bunları saklayayım, ondan sonra işleyeyim denemeyecek kadar çok geliyor bazı sistemlerde. Veracity çok geliyor ama sağlam data gelmesi lazım. Bu da veracity. Biraz burayı zorlamışlar kelimeyi ama bu da doğru. Son olarak da value. The business value of the data to be collected. Biz bu dataları topluyoruz vesaire. Topluyoruz, yazıyoruz. Topluyoruz, yazıyoruz. Endüstride şu andaki problem, özellikle Türkiye'de bu. Topluyorsun da bunu üretime dönük tekrar kullanacak kararları alabiliyor musun? Bunun business value'su ne? Mesela sizin sigara içip içmediğinizi devlet biliyor mu? Diyelim ki biliyor. Ne yapması lazım business value'su? Sağlık sigortanızın primini yükseltmesi lazım. Ki oradan adam kâr etsin. Ya da sigara içenleri erken emekli yapabilirsin. Çünkü daha az maaş ödeyeceksin. So, once you have a data, you need to have a business value. You should be able to convert it to a business value. Otherwise, it is just stored and not helpful. These are 5 V's of big data, and you can find this from many places. Actually, I took this image from one of them. Big data is related to statistics. Big data statistics also do exist. Big data industry is over $200 billion. Number of Google searches each day, number of WhatsApp messages, and converting those data into business value is very difficult. In the earthquake crisis last month, bir ay olmuş. People used WhatsApp groups a lot. Even the workers in the rescue used WhatsApp, but the messages in the WhatsApp platform are not managed. They just flow continuously. So people struggle to manage those unstructured data because you have to remember what you have seen. A lot of data is unstructured coming this way. So processing those data in an intelligent way is a challenge, and that is what we are going to do as a computer engineers and computer scientists. So there is data, but we have to process it. And today's challenge all artificial intelligence and big data and processing and inferencing, those are related to data processing. The next era of data processing is just started. In terms of healthcare, it is quite important. Each person is a data source, processing each person's data continuously. My heartbeat, my cholesterol, my blood sugar, it can be processed continuously. What is happening in my body can be processed. What I eat, for example, I shouldn't eat this, okay? So the system always will follow what I am doing, and it will guide me accordingly to make me healthier, as Edison said at the beginning. So the system will instruct me to behave correctly, stop smoking, please, so that I will be more healthy. 79 zettabytes of data was generated in 2021. 180 zettabytes of data will be generated in 2025. Interactions is increasing in a very fast rate. Data analytics, big data analytics market is so big. You can find very good jobs in big data analysis because people are collecting those data and they're just throwing those disks away. They don't know what to do, and it is old, and maybe it is collected for no reason at the end. So that's what they say. Due to poor data quality, US economy loses approximately $3 trillion per year due to poor data quality. 95%, second item is important. 95% of business says in the question, said managing unstructured data is a significant problem. More than 91% of organizations are investing in artificial intelligence and big data. Okay. These are what zettabytes is. This is the increase is tremendous. Believe me, we have to find new ways. Those ways are not yet found. We have to find new ways to process these data. And as Alan Kay said, in order to predict future, we have to invent it. People are spending a lot of money for big data because there is information. We know it is important, but we are having trouble processing it still. So yes, as I repeat, the best way to predict the future is to invent it. Why am I repeating this all the time? Because when you work with data-driven approaches allow individuals and business to watch past trends and predict future. So you can make data-oriented predictions. Some real-life problems do exist, such as this house problemi, işçi problemi. So these kind of problems can be worked with pen and pencil or with machine. If you compute this on the paper and show it, other side believes. Generally, many things that computer says is trusted, as I said at the beginning, and it is important. if the result is given by the computer, for example, in a bank, the bank teller says you have 500 liras in the account. You say, I have more. The bank teller says, the computer says 500. It is 500. So at the end, you lose. You lose the debate because what computer says is accepted as the correct value. And it's very important. Which is what data-driven culture is. Data-driven culture is about replacing the gut feeling to make decisions with facts and assumptions. You measure it, you compute it, you make statistics, and you make decisions based on computation in everything. That is what data-driven culture. Yeah. In the old days, people were thinking overnight and they come up with an idea. That is what they say acumen-based culture. In the data-driven culture, you infer your decisions, you make your decisions based on data. In future, when machine intelligence is more widespread, these decisions will be automated. Okay, so there is a video at this address about big data introduction. I am going to share this in the chat box. And today you will be watching that. One second. Today you will be watching that in by yourself.